Hey everyone, welcome back to the channel. Today, we're diving deep into a topic that's becoming essential in the AI and software development space: vector databases. Whether you're a developer, software engineer, or a client looking to understand how modern applications handle complex data, this video is for you. Let's get started. What is a vector database? A vector database is a type of database designed to store and search high-dimensional vector data. But what does that mean? In simple terms, when we use machine learning models, especially in areas like natural language processing, NLP, computer vision, or recommendation systems, we often convert data like text, images, and audio into vectors or numerical representations. These vectors capture the meaning, features, or patterns in that data. A vector database allows you to store those embeddings and search them efficiently using techniques like similarity search. Traditional databases can't handle this kind of high-dimensional data effectively, and that's where vector databases come in. Use cases of vector databases. So where do we actually use vector databases? Semantic search. Instead of matching keywords, semantic search understands the meaning of queries. This is essential in modern chatbots, customer support, or knowledge bases. Recommendation systems. Platforms like YouTube, Netflix, or Spotify use vector search to recommend similar videos, songs, or products. Image and video search, searching for similar images based on visual content instead of file names. Fraud detection, comparing behavior patterns using vector similarity to detect anomalies. Multilingual search, search a database in English and get relevant results even if the content is in Spanish thanks to embeddings. If your app deals with AI models, vector databases will likely become part of your stack. How vector databases work. Here's a quick technical breakdown. Data encoding. First, raw data, text, image, etc., is passed through a model like BERT, CLIP, or OpenAI embeddings to generate vectors. Vector indexing. These vectors are stored in the vector database using a special structure like HNSW, IVF, or PQ to allow fast search. Similarity search. Instead of SQL queries, you use vector similarity methods like cosine similarity or Euclidean distance to find matches. Filtering and metadata. You can still combine vector search with filters like product categories, dates, etc. Popular vector databases like Pinecone, Weaviate, Face, Milvus, and Qdrant handle this entire process smoothly. Vector DB versus traditional DB. Now, let's talk about how a vector database compares to a traditional one. Traditional databases like MySQL or PostgreSQL are excellent for handling structured data, think rows, columns, and exact match queries. You'd use them for things like user accounts, inventory, or transactional records. But when it comes to unstructured data like natural language, images, or behavior patterns, traditional databases fall short. Vector databases are built for this kind of work. Instead of exact matches, they support similarity search, helping you find close enough results based on the content's meaning, not just the words or labels. They're optimized for high-dimensional vectors and can handle large-scale AI applications that need fast and accurate retrieval. That said, in many cases, both systems work side by side, for example, using PostgreSQL for user metadata and Face for vector-based search. How to integrate Vector DB in your app? Let's walk through how to integrate a Vector DB in a typical software setup. Choose an embedding model like OpenAI embeddings, sentence transformers, or CLIP. Generate vectors, transform your data into embeddings. Store in VectorDB, use APIs or SDKs provided by the database. Query with new input, encode user input into a vector and perform similarity search. Retrieve and display fetch match records and display them in your app. Most vector databases have cloud offerings with easy REST APIs or Python JavaScript SDKs. Best practices and challenges. Here are a few best practices. Use the right embedding model based on your data type. Normalize vectors to get consistent results. Index tuning is important for performance. Hybrid search. Combine keyword and vector search for more accuracy. Challenges include handling large-scale updates, keeping latency low, integrating with existing systems. But with the right strategy, vector databases can significantly enhance AI features in your product. Vector databases are not just a trend, they're becoming a core component in AI-driven applications. Whether it's search, recommendations, or image recognition, they make things smarter and more efficient. If you're a business or developer looking to build intelligent search, AI features, or integrate vector DBs into your system, we can help. If you need software development services, reach out to us at contact@techtoes.com or visit our website www.techtoes.com. Don't forget to like, share, and subscribe for more tech breakdowns. Thanks for watching, and we'll see you in the next video.